Okay, so time for the afternoon. I've known our next speaker for what seems like my entire life. Rocketed to Earth as an infant from the dying planet Krypton, he has grown to be an advocate of accessibility in all of its forms. The author of a number of books, including cascading style on cascading style sheets, including CSS, the Definitive Guide, and a co-author on a book called Design for Real Life. He is also a developer advocate at Igalia, an expert in stucco, and an outlaw in Peru. He's an enthusiastic historian of Usenet-era memes and a biographical fabulist, and he's here today to talk about a massive change in CSS. Please welcome Eric Meyer. Thank you, Eric. I really appreciate that. You devilishly handsome man, you. Okay, so I'm here today to talk about has. Ready for has? Yeah. Let's get has. That didn't mean anything. I got 90 slides and 45 minutes to show them. So here we go. So this coming Saturday, just 3 days from today, it will have been 26 years since CSS1 became official. And then, 17 months after CSS1 was finalized, CSS2 became official. Things moved faster in those days because there was a lot less. And a lot of things were added in those 17 months. In a lot of ways, CSS2 was the CSS1 we couldn't agree on time. And one of the areas that got expansion was selectors, which went from a very simple set of 3 selector types to more complex combinations, some but not all of which I've shown on this slide here. All right. So primarily, what CSS2 added, not entirely, but primarily what it added was those cool little symbols that went inside the simple, what were then called contextual selectors, what we would now call descendant selectors in CSS. One of the most heavily used of those little combinators, as they're called, even from the outset, was this one. Now, I expect probably a lot of you, maybe all of you, are familiar with this one, which limits the relationship between 2 elements to that of parent and child. Okay? That is to say, at least in this case, any B that is a child of A, not a descendant of arbitrary depth, but a child. And from almost the moment this capability was delivered, developers the world over have been asking, can we reverse that somehow? So we can have a parent selector as opposed to just a child selector? In other words, can we have a way to style element A if it's a parent of element B? So one such proposal, posted almost exactly 10 years to the day after CSS2 was published, was Sean Inman's CSS qualified selectors. Don't worry, you're not supposed to read this. But in this post, Sean set out an idea that many had proposed, but in typical Sean Inman way, he did so elegantly and with some implementation insight because he had written his own applications at that point. It's an interesting thing to go back and read, actually, because it's a nice capture of sort of where things were in 2008. And I bring it up, I mention this particular proposal, not because it was especially novel, nor because Sean is an admired colleague of mine, although he is, but because it drew some of the most detailed public feedback from browser makers that had been written on this topic, and still some of the best such commentary to this day. In a comment on the post, okay, remember comments on blog posts? They're coming back, by the way. Dave Hyatt of Mozilla and Safari fame laid out the reasons why this wasn't going to work. Like, Sean's idea was just not going to work. And this is but one small quote in the middle of a very good comment, where he says, the problem is that browsers cannot store all of the information. They need to know exactly when, what to invalidate when something in the DOM changes. Okay? Because the concern here is not so much figuring out if this element is a parent of this other element. It's figuring out, is this element still a parent of this other element now that the DOM has changed thanks to JavaScript or whatever. Okay. They end up using a tainting model that inevitably, in the worst case scenarios, leads to over-invalidation. It's worth, again, not just reading the post, but looking at the comments and tracking down this, this comment from Dave. It's fairly lengthy, actually. Like I say, this is just one small quote out of the whole thing. But he really gets into, like, here are the problems, right? These are, you're asking for massive performance problems if you do this. Now, again, this was written in 2008. Things were not the same then. But I really do like this comment because, like I say, it's the first time that a browser maker kind of, it's like someone who had actually contributed, had written browser code, said, here's why this won't work. Because previously, every time a parent selector was proposed, the response was basically this. You know, not in a malicious way, it just, no. And this actually makes a lot of sense if you consider how pages are laid out and some of the things that Dave talked about. This diagram I really like. I like the schematic of the page layout process. Used in a couple of talks about container queries, which are mentioned there on the slide and also are in the links for the show. But container queries actually faced very similar barriers to adoption that the parent selector did. And I like this diagram because it shows the DOM as like the trunk and branches, and the CSS object model as the leaves that make the tree look pretty, right? And then they come together to make a unified tree of document structure and the layout rules that gets turned into layout that is then painted on a screen. Okay? But notice this part right here. Okay? Selectors are how the document and the CSS object models get put together. That's the glue. Anything that slows this step is a concern, and things like parent selectors or container queries have to be as fast as regular old selectors or regular old queries to be allowed to exist in browsers. Okay? Otherwise, page display gets slowed below 60 frames per second, and browser makers will not allow that. Oh yeah, browsers have to be able to render a page at a minimum of 60 frames per second. Did you know that? When you get right down to it, browsers are first-person scrollers. They have to keep frame rates as high as possible. That 60 frames per second is a floor. It's not an ideal target. They can't go below that. Okay? Higher frame rates, always preferred. Because given the need to support things like animations and smooth page scrolling, anything that makes those movements janky is not okay for a lot of reasons. Now, despite this, attempts have been made over the years. For example, back in the day, and by day I mean 2007, a year before Sean Inman's post, jQuery added a selector called has. Okay? And basically what it did is it told you if an element had something as a descendant. Like, if this li has a ul as a descendant, then there's a match here. Okay. This was based on an existing CSS proposal. Basically, when John Resig was writing jQuery, he looked at CSS proposals and thought, oh, a CSS proposal, this will be in browsers soon. I should support it in jQuery. We were so young then. You look at this. This is from 2007. I'm not exaggerating. That is literally when jQuery 1.1 came out. And you can say to yourself, okay, well, why didn't browsers just do that? And again, performance, right? But it already worked. Well, it worked in JavaScript, right? Which is, or at least was at the time, completely separate from CSS and had its own optimizations, its own render path. The division between them was very hard or close to impossible, depending on the browser, to overcome. And also, it was already known that a language like JavaScript, you could slow the browser down with JavaScript. Many of us probably have in the past, right? But that wasn't something the browser maker had done. It's something that a developer did, okay? It wasn't, browser makers could look at this and say, okay, sure, jQuery supports it, but here are the performance impacts it would have. We cannot ship that. If someone else wants to do that and slow their page down by running this bit of JavaScript, that's a shame but that's not us. We didn't do that. Okay. Anyway. But a similar thing was created by IO, the makers of AdBlock Plus. They wanted a way to select elements based on things they contained or were followed by, like ads, because AdBlock. So they wrote their own JavaScript thing called -adp-has, sorry, ABP, not ADP, for AdBlock Plus. This was also based on this long-standing proposal for the has pseudo class. Maybe it was also based on jQuery as well. I wasn't part of that coding. But they wanted to see has supported natively, right? So they didn't have to keep maintaining this polyfill JavaScript. So they hired Igalia, who I work for as a developer advocate, to prototype a native browser implementation of the has pseudo class in CSS. Because corporations hiring consultancies to advance web features in browsers actually is a thing these days. Okay? And it's more of a thing than I think most of us realize. It certainly was more of a thing than I realized before I started work with Igalia. If anyone wants to talk about that afterward, I would love to, but we don't have time for that right now. So, anyway, thanks to work by Igalia's Byung-Woo Lee, we have it in browsers right now. Okay? And it's not that Byung-Woo did all the implementations, but it was his prototype implementation for Chromium that kickstarted rapid advancement across the three engines, actually starting with WebKit. And I want to emphasize just how quickly this tide has shifted. This was the state of browser support for has in mid-late July of this year. And this was the state of support yesterday. Browser support went from 13% to 84% in not quite 6 months. Okay? Firefox's implementation, still behind a flag and not complete. It doesn't do sibling combinators, which I'm going to get into. But they're making progress, and it is there. You can enable has by setting a flag in about config. And anyway, Chromium-based browsers like Opera should pick up this support as they merge in newer versions of Chromium. So if you look here, Opera, Mini, if it ever picks up a newer version of Chromium, then it will pick up that support. Same thing for any of the other browsers there that are based on Chromium. So the time to start learning has and planning for it in future projects is right now. Okay? And potentially, based on your project, you might be able to deploy it right now. Like if you're doing a thing for your intranet, and your intranet, you know that everybody uses Chrome, there you go, right? For production deployment, okay, you know, we'll see. We'll get into that. But anyway, so probably the best way to think of has is as has relationship, as in B has a relationship to A. All right? And again, the styling focuses on A, not B. And it's not just a re-implementation of what jQuery did. I just want to be clear. This is vastly more powerful. And I'm going to get into why and how. So let me start out with two fairly simple examples. The first one here on the left, P has A, will select any paragraph element that has an A element as one of its descendants. Okay? The second one on the right, the P has greater than image, will select any paragraph element that has an image element as one of its children, not just a descendant, but a direct child. So to make this more clear, and to keep you all in the back, who are my people, from having to squint at the markup, let's look at these as tiny tree structures. Happy little document trees right here. In the first case, all three of these paragraphs are selected because they have an A element as a descendant. It doesn't have to be a child. It can be a grandchild or a great-grandchild or however many grade levels there are child, right? But in the second case, by adding that child combinator symbol, the greater than symbol, only paragraphs with a child image element are going to match. So the first case matches because the only descendant element it has is an IMG, and that's a child. The third case matches because while that first image is a great-grandchild, the second image is a child of the paragraph. But the second paragraph is not matched because the only image that descends from the paragraph is not a child of the paragraph. It's that span gets in the way and prevents the match. With me so far? Because we got a lot more to go. And it gets real Baroque real fast. Okay, so here's a little bit more complicated case. We want to select any element that's immediately followed by a sibling script element with a class of add.js. I use a number of ad-centric examples in honor of AdBlock+. So, in the example on the left, the div matches, and on the right, the div does not match because there's a main in the way. But if you look at the selector, I didn't say any div that has a script with a class of add.js that follows it. I said any element that has a script element with a class of add.js after it. So actually, the main element gets matched by this selector in the second example. Okay? So this one takes the complexity up a notch. Here, if a div has a script inside of it and actually has a script that's a child, right? And the immediately following sibling of that div is an element with a class of advert, then the element with that class gets matched because it's the last thing in the selector, right? So has doesn't always have to be at the end of the selector. Here I said, hey, if you've got a div that has a child script and the very next sibling of that particular div is something with a class of advert, match that thing with a class of advert. So suppose an image got stuck in between the div and the iframe in that has the advert class. In this case, the iframe does not get selected because it's no longer the immediately following sibling of a div that has a script as a child. Okay? Here we go. So, how about if we want to use has for more than one thing? That is broadly possible, with exceptions that I'll get to in just a couple of minutes here. Here, if a div has a script as a child, and it's immediately followed by an element that has a descendant, not just a child, but any descendant, with a class of advert, then the second element, the one with the advert inside of it, is the one that gets selected. Right? So you can do a has here and a has there. But like I said, there are a few restrictions that I am going to get to in just a little bit here. Okay, so I will move away from ads, I promise. Here, we're saying any element that has a descendant script with a class of add.js inside of it, select all the child elements of that element, the one that got matched by the has. So here's the select all child elements part. So because the header has a descendant script with a class of add.js, all of its children get selected, including the script that caused the has to match in the first place. Now, why do you want to select script elements? I don't know, you do you. But you can, right? So, you do need to be careful though, all right? Because consider this markup with a selector. This selector will match any div element that has a descendant element whose aria label attribute value is sponsored, right? So we were talking about Tolu was talking about aria labels yesterday. We've heard about that sort of thing, and you might say, okay, if there's an element that has the aria label attribute and that attribute's value is sponsored, I want to select a div that is an ancestor of that, effectively. And that works great in this limited example. But in the context of a complete document, things can go awry pretty fast. Because in this example, all three of these divs are selected by the selector. Right? They all have a descendant element that fulfills the conditions of has. It's likely, with a selector pattern like this, it's likely you wanted to select probably that innermost of those three selected divs, the one that has a div inside of it there. And you could accomplish that in this situation by throwing in a child combinator at the start of the has value. So keep that in mind, like we saw before. If you specifically want a parent selection, not an ancestor selection, but a parent selection, use that child combinator. Because otherwise, you could end up with a situation like making your whole page go away or something. And there is something else I want to call out here before moving on, which is a conflict between what the CSS syntax means and natural language processing of English. Okay? It makes sense in human conversation to say that that very innermost div has an ARIA-labeled attribute with a value of sponsored. Okay? But that's not a CSS has. So that ARIA-labeled div is never going to be selected by this has. Even though we say, look at that div, it has an ARIA label with a value of sponsored. But CSS does not speak English. So has really means has relationship. This selector selects a div that has a relationship to an element that has ARIA label equals sponsored. Okay? It cannot have that relationship with itself. Because CSS doesn't have a combinator symbol that means descendant, or actually rather it does, but that combinator symbol is a blank space. Right? When you put a space between two elements, you're saying the second element descends from the first element. You want to select that second element. But the takeaway here, like I say, is that no has can ever refer to itself from within the has value, if you see what I mean. There's no combination of selectors you can put inside the parenthesis of a has that will point to the element the has is attached to. The stuff inside the parenthesis can only point at other elements that are in some sort of relationship to the element that has the has attached to it. I know that's probably feels a little weird, but you get used to it pretty quickly. Anyway, now since I've been talking for a bit here about things that has makes possible, let me spend a minute or two on what it doesn't make possible, at least not yet. So, I mean, the question is, what can make a has selector invalid? Well, no has inside has. Okay? This is for performance reasons, right? Again, performance has come up here, even though, I thought performance reasons were solved and we can have has. Well, no. We've solved some of the performance reasons, but there are others that are difficult. This could change in a future version of CSS. Maybe in selectors level 7 or whatever, they come out and say, all right, you can have has inside has now, because all the browser makers basically in the working group said, yeah, we think we can support this. This looks good. But anyway, for now, you cannot put has in your has. So you cannot has while you has. Sorry. At least not in this way. Okay. Second, no pseudo elements inside has. Okay. Pseudo classes, yes, fine. You can put any pseudo class you want inside has as long as it's not has. But pseudo elements like before, after, first letter, first line, marker, slotted, none of those are allowed inside has. Okay. And third, no has inside pseudo elements. Because there are a couple of pseudo elements now that will let you put things inside them. This really only comes up in relation to shadow DOM. So if you're shadow DOMing, first of all, God love you. Second of all, you want to know this. If you're not doing shadow DOM, then this isn't really going to affect you, most likely. But you can't put has inside pseudo elements. And continuing, the pseudo element hit parade. Click. No has after a pseudo element. Okay. Will this be possible in the future? Maybe. The working group, the CSS working group, is skeptical of the utility here. But it remains a possibility at some point. Probably not soon. As of now, it's just not a thing. Don't do it. Okay? The last thing is a little different, and it's more about privacy than anything else. You can't ever match visited. Okay? You're probably familiar with this. This is similar to how you can't style visited links in ways that will change the page layout. And of the few ways you can style visited links, the DOM lies via JavaScript, or to JavaScript, about what's actually going on. Right? This is done to safeguard user privacy, which is a whole long thing that we don't really have time to get into detail here. If you're familiar with the story, this probably doesn't come as any surprise to you. If it comes as a surprise to you that you can't style visited for user privacy reasons, I'd be happy to explain why afterwards, but for now, just can't do it, okay? And thus, for this reason, you cannot and likely will never be able to match based on a links visited status, okay? In has or in really most other situations. So performance, I actually I rearranged things a little bit from the slides that I put up. The slides are still all the same. I decided I was going to put performance in the middle of the talk because I can. Anyway, a long time ago, during near the beginning of the talk, I mentioned the selector step as being critical to performance, which it is. Okay, so we're going to see this markup in just a little bit, but just consider this markup. And then consider it turned into a document tree, effectively, okay? And then if you're looking for, and this is just a simple descendant selector, I'm not doing has right now. A simple descendant selector, you want to select any element that has a class of sale that's a descendant of a div element. So the browser goes through the document tree, goes looking at things, it's like, okay, haven't found anything yet. Oh, .sale, I found it. We're going to apply the styles from this rule to that thing. And it does that for the entire document tree, okay? Like that. And then, if we decide that we're going to look for and apply styles to any del element, just go with me, that's a descendant of a p, that's a descendant of a div, okay? Again, the browser goes looking, it says, aha, I found one. Cool. And then it keeps going. It finds no more P's that have del's inside of them, and there you go. But when you have has, when you throw that into the mix, I'm going to say div has P del. You're kind of doing two DOM parses at the same time, at least in a naive implementation of this. So there's one to find the P elements that have the del's inside of them, and then one to find the divs that actually have that structure inside them. And we can, in this very simple example, you could look at it and say, well, all it has to do is keep track of where it's been. But remember, we've already seen some more complex selectors that involve has, that involve like adjacent sibling combinators and all that sort of thing, right? So it's not as easy as I'm making it look here, but I only have so much room on a slide before it becomes illegible in the back of the room, so this is what we're going with. Okay, so there's one to find all those divs that have the PDEL, and then attaching the styles to those things instead of to something else. Great. Or sorry, attaching the styles to the div instead of something else. And then, if a script comes along and does something like adds a del to the document, then it has to do that whole double parse two-step all over again, where it goes through looking, and it's like, oh, there we go, okay. I'm going to keep looking. Oh, here we go again, okay. Like that. Unless the browser flags elements when it discovers that match the has structure. So the future checks on this are lightning fast, right? After the del got added, because the browser had already done the work of going through and effectively flagging, hey, this div matches this any has of p-del, right? So then a script came along and added another del underneath a p, and the browser didn't even have to go looking through the all of the document structures necessarily. And again, I've made this very simplified, okay? Do not think this is the sum total of the optimizations that happened. But that's essentially how it works. Browsers have never acted like this before when it comes to selectors. This is not how they behave typically, but they do now. This is effectively the solution that Byung-Woo came up with in his prototype implementation in Chrome. And the performance is actually really good. If you look at the leftmost of those charts there, or really either of them, if you look at it, these are showing, the blue bars show if you have .a and then .c as class names, and the C is a descendant of A, and you toggle that, the blue bar shows the millisecond time. The one next to it is if you're toggling the B in A has B, and it's like half the processing time, right? Because remember, any layout recalculation, like the total layout recalculation, needs to be done on the order of 15 milliseconds or less in order to keep page display at or above 60 frames per second. Okay? So this was really important. And before this, for example, when Dave Hyatt in 2008 wrote, "We will never have a parent selector," he was considering parent selectors in the context of how browsers process selectors, and the chart would not have looked like this. It would have been, here's the regular descendant selector, and then for a parent selector, the thing is much higher. Okay, and this shows it's basically linear performance. ON apparently, I don't know what that means, but I saw it in a paper, so whatever. The tree size there on the right side of those charts is 8,000 DOM nodes, effectively, which most of if you're running Twitter, sure, that probably seems laughably small, but for most of us, 8,000 DOM nodes is a lot of DOM nodes for a given page. And you're getting performance at the 0.15 millisecond range in that situation. Okay, great. Thanks for the nerd dive there, Eric. But how can we use it? And honestly, my answer is, how can't you use it? I mean, seriously. There are some small limits on has, as we saw a few minutes ago, but for nearly every why can't selectors do this question I've seen in the last 25 years, has covers pretty much all of them. So, and just to be clear, the rest of this talk is only scratching the surface. New patterns are found every day. I literally added a slide to the talk 3 hours ago because I came across a new pattern. Anyway, for example, let's suppose we have item cards in a catalog, and we want to style the cards based on what's in them. All right? This is the sort of thing that we'd usually write server-side JavaScript for, add classes to the cards as we need them. But with has, we don't need any of that. No scripting, no extra classes, just lovely, lovely CSS. So to see what I mean, here's that markup that we saw just a few slides ago. Here it is again. Represents one of these cards, and this is the total markup. Okay? I didn't take out any classes, I didn't take out any IDs in order to make this. The only thing I took out was the values of like the href, src, and alt attributes in order for brevity. Okay. Now, let's take out the stuff, and then each of these cards looks like this. That's, I'm not counting the actual content of like the paragraphs, but we don't need to see that here. Okay? So it doesn't need a bunch of classes or nested elements to render. These cards do clearly have a fair amount of CSS applied to them to like size and color the text and the images and stuff. I'm not going to show that all here because it's just regular CSS. But there are a few classes in here, it's true, mainly to flag the bits of data that need special attention and don't have appropriately semantic HTML elements to represent them. Like we don't have sale and coupon elements. I don't know why, but we don't. So let's label the cards that have these sale and coupon classes inside them. We'll do it like this. Okay, so that high-quality baseball cap is both on sale and has a coupon. Ooh. Okay, so, and as you can see, the paragraph that is called .sale has the word sale inside of it probably, and it gets turned into a little red ribbon. That's not an image, it's text. And the coupon paragraphs are made green thanks to some CSS that was being applied just off screen. Great. So if we want to draw extra attention to the products that are on sale, we can use has to give the divs a light drop shadow and a red 2-pixel border. So any div in the gallery that has a descendant sale classed element gets selected here, and it gets those styles. And then, similarly, we can also add a little bit of a green glow to the insides of cards with coupon codes. Probably not coming through real well in the back, so it's a little bit subtle, but we don't want to upstage the sale styling too much here, particularly on cards where there's already sale styling, like the baseball cap. All right. So the cap has been matched by both has rules. So it has a green glow and a red border and a drop shadow. That's fine. You can do that. And for that matter, as we saw before, we could combine two has pseudo classes in a single selector and style the product codes where the items are both on sale and have a coupon code. That's this one. Thus combining the red border with a green outline and removing that inner green glow, but making the drop shadow stronger. Okay. But then again, with a slightly different selector, we can apply those styles to any product card for an item that is on sale or has a coupon code by putting a group selector inside the has. Instead of chaining the two has pseudo classes together, basically chaining two has pseudo classes together is saying, give me an element that has this and has this. Using the group selector means saying, give me an element that has this or this. That might be a little much, though, so let's pull it back. Where we had these three rules that had these results shown here: the red border with a drop shadow for sale, subtle inner green glow for coupon, and a combination of the two with an extra drop shadow for items that are both on sale and have a coupon. Okay. Those previous rules did assume that the price and coupon paragraphs would be children of the card's div. But what if we decided, for whatever reason, to wrap them in a div of their own? Maybe the CMS demands it. Well, in that case, we take the rules that we had before and remove those child combinators, and the rules will continue to work just like they did before. Okay. There are so many patterns we can create with has. It's amazing. We can style the canvas of a page that has somewhere in its markup an element with a class of about page. Or we could style any header with a class of page that is part of a body if the body contains a nav element with a class of subnav. Right? That header and that nav might have nothing to do with each other. But you can still say, this page has a nav element with a class of subnav. I need to treat headers differently here for whatever reason. Or, well, page headers differently. Anyway, we could style any element with a class of hero whenever it has, somewhere inside of it, both a hyperlink and an element with a class of by, which could be the same element, but doesn't have to be. Oop. Let me break this down in a little more detail. This is the first example where the HTML gets selected if one of its descendants has a class of about page. So basically, as long as about page shows up somewhere in the document, other than on the HTML element itself, this selector will match. You could literally put class equals about page on the head element if you wanted to, and this selector will still match. Again, I'm not saying that you should do that, but you could. In this example, any body element that has a descendant nav with a class of subnav, then any page class descendant header elements get matched. And in the first example, the nav with a class of subnav is inside the header, but in the second example, it's not. Okay? And in this case, the header gets a margin block end of 0. And here, we have two scenarios in which an element with a class of hero is matched by the has. In the first example, there's a link, and then there's a span with a class of by. In the second example, the link is also the element that has a class of by, but that's okay. Both has conditions are met, so the has is matched and the header gets styled. Here are just a few more patterns. Well, I have several more patterns. Who am I kidding? But here are some more patterns to consider. In the first case, right, like I said, these can get Baroque. Any div that has an H2 or an H3 as a descendant, where that div is the immediately following sibling of a div that has a table with a class of data inside of it, give it a much bigger margin block start. Okay? Or any div that has an element that's not an IMG. Okay? Doesn't matter what that is, but any element that's not an IMG element, if a div has one of those, then it gets a different inline padding. Or in this case, any div, and I always have to look at this, that does not have elements other than IMG inside it will get a border. Okay, this is a little hard to follow, I admit. But what it basically means is if a div has 0 or more IMG elements and no other elements of any kind as a descendant, then it gets selected. Kind of a rare use case, I admit, but maybe you will run into this, where you'll have, hey, some of our divs are just have images inside of them, and other divs have multiple elements, different elements, and we want to style them differently. You could start decorating classes around, or maybe you don't have to. Anyway, heck, just this morning, right, like 3 hours ago, I wrote this slide, and I wrote this, I included this slide because I wrote this CSS to add Twitter-style alt labels to images on mastodon.social when they have an alt attribute. Okay, the way that on Twitter, if an image has alt text, it has a little alt badge. Mastodon.social doesn't do that. I wanted it to, so I wrote user styles, and I used has. They're not exactly the same as Twitter's alt badges, but they're very similar. And I actually blogged about that on meyerweb.com shortly before lunch. So if you want to see the whole set of CSS, you can find it there. But I found this really useful because rather than having to try to figure out, okay, is there some kind of other pattern? Are there other classes up above this media gallery _ item thumbnail BEM, whatever name it is, when an image has an alt, which it probably doesn't. There's probably the only thing I have is the image has alt attribute, and it's also a descendant of this link inside of it. In the past, I would have been out of luck. I would have had to write some JavaScript to try to parse the entire DOM and add classes that I could then style. Now I don't have to. Right? I just say, hey, and I could have put it in a.mediagallery item thumbnail because they're, so far as I can see, they're A elements. But why restrict myself? If I have a media gallery with item thumbnail and it has an image with an alt inside of it, make it position relative, and then as a generated content, put in a little alt badge and style it and make it look nice, and boom, done. Super handy. Here's another technique that combines sibling and child combinators. In this example, any H4, that is immediately followed by a block quote, it gets this 1 pixel solid orange border. But if the H4 has an adjacent sibling block quote where that block quote has a child paragraph element, then the border width is bigger. In this case, I've selected any A element inside the nav that has a following sibling with a class of current and added a symbol at the end of each one. In other words, this creates a preceding sibling selector, not a following sibling selector. So the only A elements selected here are those that have a sibling, a following sibling, with a class of current, right? Or we can also apply styles conditional on the length of an element. And in fact, in this case, if a table's body contains a row that is a 7th child of the T body, then every odd-numbered row that's a child of that table body gets a silver background. So I'm applying zebra striping, but only to tables that have more than 6 table rows. Similarly, could apply the usual 1em of margin to the top and bottom of, or to the start and end, of unordered lists. But in cases where a list doesn't have a 4th list item, child, in other words, any list that has 3 or fewer list items, we can double the usual block margins in order to more obviously set that tiny little list apart from the rest of the text. Now, maybe you don't like that negation selector approach, so there is a cleaner way to do this. Click, which is to say that all UL elements should have a 2em block margin, but then if any unordered list that has a 4th list item child, then they get shorter margins. It's the same effect, it's just a different way of doing it. What else? How about a version of focus within? There's a focus within pseudo class, by the way. that selects the element only if one of its descendants has the focus, but not the element itself if it has the focus. So this is slightly different than focus within. Or something completely new, like styling an element if any of its descendants are targets of a fragment identifier, which is what that second one does. And forms are a great place to use has. Labels and inputs and selects and text areas and so on can be supercharged with simple has selectors like these. For example, as in that first rule, you could fill an entire form's background in light red if any one of the fields inside of it is in an invalid state. That might be a bit much, but you could use this set of selectors as applied to this markup. Right? All three rules are set up so that if a label is followed by an element that's required, they'll be matched and the label will be selected. So some of you may have done a thing where you had to wrap a label around an input in the text because you needed descendant selector stuff and then you had to add classes to. No, not anymore. The label can be next to the input and used to point at it. Okay. So in the case of the third rule, that's only matched if the following element is both required and invalid. Right? So you can see that the email address is bold and red. And here's what happens when a user interacts with these inputs. Right? So typing along. Oh, now it's invalid again because, oops, typo. Oh, okay. And then go down there. So the red was only present when the following input was in an invalid state. And here's the same thing stated two different ways. Remember I said how cool is? I really like is. Basically, any element whose next sibling is an H1, H2, or H3 gets an end-block margin that's essentially 1/3 the size of the block size of the viewport, which is the same as height in languages like English or French or Arabic or Hebrew, that sort of thing. Okay. The first way you do it is, does this element have a following sibling H1, a following sibling H2, or a following sibling H3? The second way is doing the exact same thing. It says if the element has a following sibling that is H1, H2, or H3, you get the same result. It's like I say, two different ways of expressing the same idea. And we can bring this all back full circle and create the don't underline a link that has an image in it, which was like the canonical use case for why we needed a parent selector since 1998. So in this case, and then both of these are going to match. Okay, the href has a child that's an IMG, and it could have said descendant, but in this case I decided to go child just to restrict it a little bit. Then turn off the text decoration, which basically means turn off the underlining. Now, is that a great idea? Maybe in this case, no, but you might have a situation where things have to look more like buttons, and you can do these sorts of simple combinations. So, has performance. Performance is only going to get better as new optimizations are found. I showed those charts of how much more performant has can be in certain situations, and it's only just been implemented. Optimizations have only gotten started. More and more optimizations will be found as things move forward, as well as CSS selectors, engines in general, getting improved. And there's power in just how far and wide you can cast your selector's net. You can literally set up a has that styles an H1 differently based on what's in the footer of the site. Okay? Again, should you? I don't know. Maybe it totally makes sense in the context of whatever you're working with. Maybe you're trying to style the output of a CMS that you don't get to change the templates of the CMS. Now you don't have to. Okay? So, as Tolu reminded us, with great power comes the need for great care. I paraphrased. But remember that there's so much here. And like I said, literally finding new patterns, new useful patterns on a daily basis. There's so much more that we haven't figured out that anyone in this room I'm sure could go back to your project and look at, where you're adding classes from script, and realize we can take all of that scripting out now. We don't have to run this on the server side anymore. We can put out simpler markup that will compress down more and ship faster over the wire, and write these CSS selectors that are highly performant and highly powerful, and let us do a lot more with less. So thank you very much, and I look forward to questions. Thanks, Eric. That was great. Anyway. Okay, so, sorry, checking things out. Okay, so one question was, what can we, well, why did it take so long to figure out this performance stuff? Because you'd think that someone could have figured out this sort of caching approach the flagging approach. It involves caching. It's complicated. Anyway, someone could have figured out this whole flagging thing earlier. And why didn't they? And in part because, well, the people working on browser engines have been working on browser engines for a long time, and have gotten used to doing things in certain ways. And it really needed someone from the outside to look at it. At least this is my opinion. Okay. And so the thing is, getting that outsider perspective is difficult when you're inside a team. So it basically had to wait for someone who was willing to hire a firm like Igalia to try to implement a thing like has, to see if it was even possible. I mean, that was the interesting thing about, contracts like Igalia's, where, or like IOs with Igalia. Basically, it was IO saying, we will pay you to try to implement this as a prototype in Chromium to see if it's even possible to make it performant, right? They were willing to find out if they were going to have to keep supporting this polyfill or not. Turns out it was possible to make it performant. Awesome. And then, yeah, that kickstarted, like I say, the whole thing. Once it was shown to be possible, it became a little bit of a race. There got to be a little bit of a competition to see who could ship it first in production. And the WebKit team won that little competition, and more power to them. And there's Antti Kosvo is I believe the person who did most of the implementation on WebKit, and he put up, I think it was December of last year, his prototype where basically he used JavaScript to create this huge table. And I mean like 1,500 cells in whatever the square root of 1,500 is. And hovering over any cell would create an X pattern of like filling in the cells that would create an X pattern. And it was literally all done with has, and it was just like, and completely no jank or anything. I think that was the first time, sort of in public, people saw that, whoa, this thing actually can be very performant. Okay. Next question. On caching, all right, nice. If the parent is flagged once the condition is met and then no new parsing happens, and then the markup is changed so the condition is no longer met, is the caching flag then removed? I don't know all the details, I have to admit. So there's a link to a talk that I put in the show notes to a lightning talk from Blink on 17 by Byung-Woo. I think in the Igalia channel, I should look to see if there are more has videos there that I could link to. I'm not sure of the exact cache invalidation or flag invalidation routines, but they are, like I say, they're still quite performant. And there are there's a talk, I think the slides I linked to talk about, here are some areas that we're still not great at, like that the routines still aren't real great at, and that might be in there. But unfortunately, I don't have the full details. But at any rate, I think that's it. That's all I have time for. So thank you very much for listening, and I hope you do awesome things with HAS.